Hello, I would like to illustrate thought process in solving math problems. And I'm going to pick the example of using a table of values to find the polynomial that generates that table. So here we have a table, values of x going from 0 to 5, and the values that correspond to that. And below, I've shown the function that will generate that. The problem is, how do we find that function from those values? So let's start off with some curiosity and looking at patterns. If we take the numbers from 1 to 5 and square them, we get the numbers 0, 1, 4, 9, 16, and 25. If we then subtract the preceding number from our current number and do this with each number, we get the next row. And we observe that that is a series of odd numbers. If we then subtract them, we get 2 for each number. And if we did once more, we get 0. But later we're going to find our interest is to note that the fact that it took 2 subtractions to get down to a set where all the numbers were the same. Okay, now another thing out of curiosity, you'll notice we're missing numbers here. And so what I basically did was put a 2 in here and see what was needed to generate that. So -1 plus 1 is 2. In order to get from here, -3 from -1 gives us +2. And as we can see, we can work our way back up and discover that if those numbers are being generated by our series going backwards. -1 becomes -1 squared is plus, and -2 is squared. So these are little things that will help us to understand this problem a bit better. Okay, so now we look at just the numbers 1 through 5 and take the differences, and we get all ones. So at a power of 1, it takes us 1 step to get the numbers the same. If we go to the power of 3, 0 from 1 is 1, 1 from 8 is 7. That's 1 subtraction. 1 from 7 is 6. And 6 from 12 is 6. So we get all 6s after 3 goes. These patterns seem to have a ring with me from past experience. So the 1, 2, and 6 look like they could be 1 factorial, 2 factorial, and 3 factorial. Well, then if I would do the 4th power, if my speculation is correct, then it should be 24. And so I took 1 squared is 1, 2 to the 4th is 16, and so on down the line, and did the subtraction. And sure enough, after 4 lines, I got 24. I'm not going to choose to explain what the formula that goes behind these because it's not pertinent to our conversation, but it's something that should be of interest. Okay, now we're going to do one other thing, and that is we're going to take all those ones from this first one, multiplying by 7, and the numbers that were in the power of 3, we're going to multiply this row by 5. So this becomes 5, 40, 135, etc. And so we now start subtracting these numbers, and we get 30 at the 3rd line. Well, we remember when we did multiply by 5, we got 6 factorial or 3 factorial or 6 at that line. And 30 divided by 6 is 5. So this gives us a way of determining what number that difference was multiplied by. Okay, so now we're going to take another step where we're going to take and add those 2 series together. So the 7 plus 5 is 12, the 14 plus 40 is 54, and so on. And now we take this series and start subtracting. The first line we get 1242, which doesn't match anything along the way. But when we go down to the next line, we get the same as we did for the 3rd power. And the reason for it is because for the 1st power, it had zeros. So its impact now disappeared in the sum. Okay, so now we see a basis for what we can build upon here. And so what we're going to do is find a practical use for this difference things. So I now take my function 2x cubed minus 4x squared plus 5x plus 6, and I substitute in the values of 0 through 5 for x. And I show the calculations that are done along the way. Okay, and so when I perform these numbers, I get 6, 9, 16, 39, etc. I take these numbers down here, and I do a successive subtraction. And I finally get 12. Well, I know that it would have been 6 factorial for the third level. So I divide the 12 by 3 factorial, excuse me, and I get 2 as the answer, which is what this was multiplied by. So now the question is, how do I find the coefficients for the other thing? Well, somehow, and this is where the originality comes in the thought process, I have to find a way of getting rid of the x cubed. Okay, and what I basically have to do is subtract out these multiplications here of the different values cubed, which are these numbers down here. Okay, so what I then do is take, and notice I've written those numbers down here, and I'm subtracting them from the numbers I got from the cubic part. And when I get that, I get these numbers 6, 7, 0, minus 15, 38, minus 69. We look, if I take the function without the x cubed in it, I get the same numbers. This is just a validation of the idea. Okay, and now I do my subtractions again. But this time I only get 2 subtractions, which implies I'm dealing with something squared. So I divide by 2 factorial and I get minus 4, which is the coefficient for the x squared. Okay, so now we've seen how to find x squared. And of course, the next question, how does we find the coefficient of x and the constant term? Okay, and so what we basically showed was how to find at least for the first 2. So now let's move on to the next one. Okay, in this case here, if we got rid of the minus x4, we would be left just with this row, and we add them up, we get 6, 11, 16, 21, etc., which is down here. So after I finished with the x squared term, I took this term and subtracted from it the values that would have come from the removing of the x squared. So that would have been 0, minus 4, 16, etc. We can see it right under here. We can see that line. Okay, and when I do the subtraction, I get these numbers, which match this again as confirmation. And I do one more subtraction, and I get 5. Since I only went down 1 level, I divide by 1 factorial. Okay, and that gives me the coefficient for the x. Okay, now again, I do the same thing. I move this up, and I subtract from it the numbers of 5x. Okay, and when I do that, I get all 6s. I don't go any further. I'm now at the first line. So this now would be 0 factorial because I've moved no steps, and I now get the coefficients. Okay, so we saw the process. Basically, the trick in here was to try to get rid of these other terms in order to be able to find the coefficients for all of the numbers in the expression. Okay, now, all of that was done for educational purposes. Let's now show how we actually solve the problem rather than showing the support from it. So here is the function. We do not know what the function is. We subtract from it each number from itself until we get down to 12. Since it was 3 steps, we know it's a cubic polynomial, and 3 factorial divided into 12 gives me 2. Then we take this over here and we want to subtract out the cubes. So since it was 0 cubed times 2 is 0, 2 I have to be a little bit careful when I'm doing is okay, so I'm subtracting out these terms have to be, yeah, they are the cube term. So 1 cubed was 1 times 2. 2 cubed is 8 times 2 is 16. 3 cubed is 27 times 2 is 24. So I'm subtracting out the x cubed there. And this gives me these numbers here. Now I do the subtraction and I get -4. Well, minus 8 divided by 2 factorial gives me the -4. That was this coefficient here. Now I take this term and move it up here, and now I have to start removing the square terms instead of the cubic terms. Okay, and since -4 is my factor, -4 times 0 is 0. -4 times 1 is -4. And if we took 4, since these are square terms, -4 times 2 squared gives me -16. So again, these were cubics, these were squares. These cubics were multiplied by 2. These cubics are being multiplied by -4. Now do my subtraction again, only one step. So I get 5 divided by 1 factorial is 5. Move this number up here, and now subtract the x terms, which are 5 times 0, 5 times 1, and so on. And when I subtract them, I get these 6's, which are my constant term, since there was no more steps beyond that. So this was a way that we could find a polynomial. Now, this trick will not work if the numbers are not in sequential order as we have here, or if this is not a quadrilateral. But this should work for any quadrilateral, no matter what level it is. And you can see the simplicity of the operation, but it takes a little practice as we learn to get our cubed function, our squared function, our linear function, and our constant function. And once we do this, we find that this is faster than some of the other recommended techniques, such as using simultaneous equations to find the coefficients, Lagrange method, or the Newton method. So I'd like to thank you very much for listening to this presentation. This was presented from the Math and Physics Exploration, which is a nonprofit museum in Poughkeepsie, New York. And if you'd like some more information, please contact us. Thank you very much.